Welcome to this session. This session, we discuss another problem on trigonometric substitution. So we are to find the integral of the x over square root of 25, x squared minus 4. And we have the restriction that x should be strictly greater than 2 over 5. So let's see how we solve this solution. So first, we rewrite the integrand or the radical in the integrand in the form x squared minus a squared. This is how we achieve that. So we have the integral of 25 x squared minus 4. This can be written as the integral. So I can write 25 and then into brackets x squared minus 4 over 25. There's nothing I've changed, still the same expression. And then we know that the square root from our basic algebra, root a be the same as root a times root b. So this is the same as root 25 times root x squared minus 4 over 25. And root 25 is 5. So we can write it as 5 square root x squared. And this can be written as 2 over 5 squared. So we have a radical of the form square root of x squared minus a squared. Hence, we use the trigonometric substitution of x equals to a sec theta. And since we have square root x squared minus 2 over 5 squared, if we equate this one to x squared minus a squared, then you should be able to see that a is 2 over 5. So which implies our substitution is x equals to 2 over 5 sec theta. So that's the substitution. And then this theta should be an angle between now dx will be 2 over 5 sec theta tan theta d theta with this restriction. And then when you say x squared minus 2 over 5 squared, then it's the same thing as saying 4 over 25 sec squared theta minus 4 over 25, which is the same thing as saying 4 over 25 into sec squared theta minus 1, which is the same thing as saying 4 over 25. Then this is the definition of tan squared theta. So it tells us that the square root of x squared minus 2 over 5 squared should be the square root of 4 over 25 tan squared theta. And this should give us 2 over 5 tan of theta. So this now implies that the integral d theta dx over square root dx over square root of 25 x squared minus 4 is the integral. Now dx, remember, we have already calculated dx. So 2 over 5 sec theta d theta, sec theta tan theta d theta. So 2 over 5 sec theta tan theta d theta. This one, we had 5, and then the square root of x squared minus 2 over 5 squared. And that square root of x squared minus 2 over 5 squared is 2 over 5 tan theta. So with this substitution, then you see tan theta and tan theta cancels out. 2 over 5 and 2 over 5 cancels out. So we remain with, this will be 1 over 5 integral of sec of theta d theta. And this is a standard integral. So this will be 1 over 5 ln of sec theta plus tan theta, and then plus c. But you don't stop here. Remember, theta is our own creation. So go from definition. Since x is given by 2 over 5 sec theta, then in the same language you're saying sec theta is equals to 5x over 2. Now you draw a right angled triangle. So name this one theta, this 90 degrees. Remember, sec is reciprocal of cosine. So if you know how to find cosine, you should be able to define sec. So sec is hypotenuse over adjacent. And so this will be square root of 25 squared and 5x squared minus 4. So from this one, tan theta will be opposite of adjacent. So square root of 25x squared minus 4 over adjacent, which is 2. So hence, the integral of dx over square root of 25 x squared minus 4 is nothing but ln of 5x over 2 plus square root of 25 x minus 4 25x minus 4, 25x squared minus 4, and then we divide by 2. Then plus constant of integration, c. Remember we had 1 over 5 at this point here. It's a 1 over 5. So this is the solution to that given problem. Thank you.